Hello, we are Team Defense of the Antediluvians, and our project is predicting Dota 2 accessory price changes based on game updates.
So our project focused on the question of does a game update would influence the price of accessories in the market? If yes, then how does that update influence the price of accessories? So basically, we believe that for esports games, game update is a very crucial part of the industry, and each gaming update might have some influence on the accessory, meaning some gaming items, the price of that items that might be influenced by game updates. And that is very important to esports gaming providers because they make a lot of money from, a lot of the profit they make is from the accessory price market. So we picked the esports game Dota 2 to be our target of investigation because it is not only one of the most developed game, but also it has a pure accessory price, which means that the game accessories does not make a hero or a character in the game become stronger or weaker. It only change the appearance of the hero. So we believe that this will not influence by the balance of the hero itself, but purely reflect the impact of game update on the accessory price. So our methodology goes the following. First, we scrape the data from Steam accessory market designed for Dota 2, and then we summarize the game update data based on the update log from the Dota 2 website. And also we use some predict model to investigate the relationship between accessory price and game updates. Then I'll pass on to Danielle to talk a little bit about how we get the data, how we scrape the data.
So we collected 3 different data sets: items, heroes, and item hero pairs. Items table contains item name, item median sale price, and item transaction volume for each day. Heroes table contains hero name, whether it has been strengthened or weakened, whether the hero is new, and whether it has been remodeled for each day. And item hero, which maps into each item an associated hero. So we first scrape for the accessory or item price over time from the Steam community market. The median sale prices charts provided by Steam look like stock price charts. And also, after we scrape the item data, we look up the game update dictionary. Since we want to investigate how game updates could influence the item price, we categorize game updates into 4 different categories. So hero strengthen: if the game provider decides that a hero is too weak based on its performance in professional championships, this hero would likely be strengthened in multiple ways. Hero weaken: on the opposite side, a hero would also be weakened in multiple ways if it is too strong that makes the professional matches less interesting to watch. Hero remodel: a hero could be remodeled to invoke fandom. The remodel includes changing the appearance of this hero as well as its ways to cast spells. New hero: a new hero might be introduced, although they might not have accessory items attached to it. So finally, to know which hero is associated with a certain item accessory, we scrape the item display pages for the hero names. We also did data preparation to get our final table. For example, we filled all NAs. We typecast some columns into different types. We also removed heroes without identifiable items, and we joined all 3 data sets together. Next, Kevin would talk about modeling.
Thank you, Danielle. This is our modeling section. For all of our modeling, fundamentally, we are operating under the heuristic that the strength and weakness of a hero influences the market for its accessories and corresponding consumer behavior. And this is because we believe if a hero is particularly strong at some point, then a lot of people will try to use it, which means we can expect their accessories to be more desirable. Conversely, if a hero is very weak at some point, it's reasonable to guess that less people will use it, which means their accessories will become less desirable, less people will want to buy them, and so on. We model two things. One is item price, and the second is item volume. We model both using how much a hero is strengthened, how much a hero is weakened, whether a hero is remodeled, or whether this hero is just entirely new. The models we used are linear regression, decision tree, and random forest. For linear regression, if we look at the coefficients, we can see that actually strengthening and weakening both are negatively correlated with item prices, which means they push down overall prices somewhat. However, the observation of note for us is that the magnitude of the coefficient for strengthening is much smaller than that of weakening. And this may be because we believe in general, adjusting a hero's power level results in an influx of transactions for accessories, whether it is strengthening or weakening. And that helps to push down overall prices because of added supply. With our decision tree, we can see that even though both strengthening and weakening actually leads to decreases in prices, it's strengthening that has a larger impact. A closer inspection of the structure of a decision tree shows us that large strengthenings lead to increases in prices. That makes sense because if a hero has a large strengthening, then its appeal goes up, which means people would flock to those heroes, and that raises demand for the accessories. On the other hand, moderate to small strengthenings tend to lead to smaller increases, if not downright decreases in prices. And weakenings in general cause decreases in prices, mainly because if a hero is weakened, then this hero is less likely to win, which means people are less likely to use it. And our random forest model confirms what we see in our decision tree, which is that strengthening is more impactful to item prices than weakening. Some possible causes include ownership bias and loss aversion that prevents people from selling accessories. Ownership bias, in this case, would be maybe the owners are reluctant to part with their accessories, maybe out of sentimental reasons. And loss aversion, it just might be that people prefer to buy them instead of selling them.
So with volume, linear regression tells us that between strengthening and weakening an accessory, strengthening is the one that stimulates the market more. However, the one with the largest effect, in this case, is remodeling. It makes sense because when a hero is remodeled, its fundamental mechanics changes, and people would have strong incentives to buy or sell the original accessories. This means that while remodeling occurs rarely, the decision tree and random forest both give very small importance to it. It has the largest impact. Otherwise, the results for volume are similar to those of prices, with strengthening being more influential for volume than weakening.
Thank you so much for listening to our presentation. Then we come to the conclusion of the presentation. Just to briefly summarize the 2 points we made during the predictive modeling process. First of all, we discovered that strengthening the hero leads to increased fandom with lower accessory price attached to that hero, but weakening a hero leads to decreased fandom with lower accessory price attached to that hero as well. Remodeling a hero will lead to a massive increase in volume. Based on those discoveries, we think that for esports gaming providers, and they could have some strategic gaming updates scheduled. So first of all, they can split a large strengthening event into consecutive strengthening to maintain and foster fandom in that sense. And also for balance purpose, gaming providers should sometimes weaken a hero, but however, they could break the hero weakening into a weakening followed by a slighter strengthening to mitigate the fandom decrease, as well as keep the game balance. And also, they can strategically adjust and replace heroes to help increase accessory revenue and cultivate player engagement and ownership. Thank you so much for listening.